Hello everyone. Welcome. Today, we're tackling a common problem when working with PyTorch, CUDA out of memory errors. This can be frustrating, but don't worry. I'll share some tips and tricks to help you manage your GPU memory and keep your training running smoothly. Let's dive right in. First, understand the problem. CUDA out of memory errors happen when your GPU runs out of memory while trying to perform a calculation. PyTorch models, datasets, and intermediate computations all consume GPU memory. If you're running a large model or using a big dataset, you can easily hit the limit. So, what can you do? Number 1, reduce batch size. This is often the easiest solution. Your batch size directly impacts the amount of memory needed. Try having it and see if the error disappears. Remember to adjust your learning rate accordingly if your training is affected. Number 2, use smaller models. Consider using a simpler architecture, especially if you're just starting out. Pre-trained models like MobileNet or SqueezeNet are much smaller than models like ResNet 50. Transfer learning can help maintain good performance with these smaller models. Number 3, enable gradient accumulation. This allows you to simulate a larger batch size without actually loading it all into memory at once. You calculate gradients for smaller batches and then accumulate them over several iterations before updating the model's weights. This uses less memory because you don't need to store all the intermediate gradients for the entire large batch at once. Number 4, use mixed precision training. This technique utilizes lower precision floating point numbers, like FP16, instead of FP32. It dramatically reduces memory usage and often speeds up training, but can sometimes introduce instability. PyTorch's torch.cuda.amp package makes it easy to implement. Number 5, clean up unused memory. PyTorch sometimes holds onto memory even after it's no longer needed. You can explicitly free this memory using torch.cuda.empty_cache. Call this function periodically, especially after operations that consume a lot of memory. Number 6, move data to CPU when not needed. If you're not actively using a tensor on the GPU, move it to the CPU using .cpu. This frees up valuable GPU memory. Make sure to move it back to the GPU before using it in calculations. Number 7, use gradient checkpointing. This technique trades computation for memory. It avoids storing intermediate activations during the forward pass and recomputes them during the backward pass. This can significantly reduce memory usage, especially for very deep networks, at the cost of a slightly slower training time. Finally, monitor your GPU usage with tools like NVIDIA's Me. This will help you understand how much memory you're using and identify potential bottlenecks. That's it for today's tips and tricks for handling CUDA out of memory errors in PyTorch. I hope you found this helpful. Thank you for watching. If you enjoyed this video, please leave a like and subscribe for more content. Consider supporting the channel. Let me know in the comments which tip helped you the most. Happy coding!